Welcome to qnawire.
Over here we're asked to assess which one is going to have the largest rotational constant. Remember that the rotational constant is going to be related to, well, something. So the rotational constant is going to be related to the moment of inertia. And the moment of inertia of a molecule is equal to the reduced mass times L squared, longitude squared. Recall that this is only valid for diatomic molecules, and the reduced mass is going to be equal to m1, m2 divided by m1 plus m2. The value for the rotational constant is going to be equal to h bar squared divided by 2 times the moment of inertia. So this is going to be equal to h bar squared divided to 2 times mu times L squared, where L is the distance in between both of the atoms. So that means that B and mu are inversely proportional to each other. Inversely proportional. Another way to put this is that B is going to be proportional to 1 over mu, directly. Okay? So now the only thing that we need to do is to calculate mu. I'm going to do it in atomic mass units because since we're only comparing, it doesn't really matter what is going to be the result. So over here, we're going to have chlorine 35 with a single hydrogen and the other one with deuterium. Remember that deuterium is going to have an atomic mass of equal to 2. And for this case, we're going to have 35 and 1 in our formula. This is going to give us a reduced mass equal to 0.9722. Just as an example of calculation, this would be 35 times 1 divided by 35 plus 1. Okay? And this is going to be, of course, in atomic mass units. Atomic mass units. So for the second case, now we're going to have 37 and 2. Remember, the deuterium has a mass equal to 2. This is going to have a value of 1.8974 atomic mass units. For the next one, we are going to have chlorine 37 with hydrogen 1, so 0.9737. And for the last one, we're going to have a value equal to 1.892 atomic mass units. So we want to know which one is going to have the largest rotational constant. The largest rotational constant means the lowest reduced mass, and that is going to be HCl with chlorine 35. This is the lowest value for mu, thus the highest value for B. Of course, we are assuming here that the bond distance in between hydrogen and chlorine and deuterium and chlorine for both of the isotopes that we're considering here is going to stay constant. So that would be all. Thank you very much and have a good one.